So the last section of chapter 12 is relative motion. Relative motion is dealing with relative coordinates, and the problem with this chapter is that it's good to know what it is, but it's one of those chapters that feels like it's kind of left alone up until chapter 16. Chapter 16, this is crucial to what you're doing, and you will eventually use this significant amounts of time when you're solving problems dealing with rigid body kinetics and kinematics. So when you're dealing with this is the type of problem you're going to see are two airplanes leave an airport, they travel, one travels in a direction of north by northwest, and the other one travels north by northeast, and you're supposed to then calculate different velocities and all of their relative velocities one to the other. But the important point here is that I have a particle that is located at some distance from an origin point. So this is an absolute fixed point, but I want to reference this everything with respect to this point. So I have a second coordinate system I've defined, x prime, y prime, and it's a certain distance away from B. Now B I've already defined with respect to the origin as well, and it's a distance r sub B. And if I do that, I can say the distance from A or from B to A can be defined with respect to an equation written like this. RB is equal to R sub A plus RB with respect to A. So if I write that, I can say A is here, B is where I want to go, and now I have a triangle that describes all the motion, or all the positions. I can take the derivative of all of those terms, and if I do that, I can say drB dt equals dra dt plus drb with respect to a dt, and that becomes the second equation right here. If I take its derivative, I get the third equation. But the way to understand the notation is that if I want to calculate the position of B, I want to sort of have this term cancel out the denominator term on the second variable. So RA plus RB with respect to A. If I was looking for RA, I had to write RA equals RB plus RA with respect to B. Velocity B equals velocity of A plus velocity B with respect to A. Acceleration B equals acceleration A, acceleration B with respect to A. You can solve these problems a number of different ways, graphically or with trig. Just make sure to carefully define your reference positions. And again, you'll see a couple problems we'll do some examples in the course, but they're there to help you, and this is just a quick summary of that. Thank you, and we'll talk.